Hello, welcome to my presentation about the Lagrange Remainder Theorem. My name is Liu Runyuan from Xiamen University, Malaysia. And here's the summary about the presentation we'll go through today. First one, we will go through the Cauchy's mean value theorems. And then we will use that theorem to prove the Lagrange Remainder Theorem. So let's look at the Cauchy mean value theorem first. Cauchy mean value theorem is its definition is that suppose the function f between a to b to r and the g in a closed interval ab to the r are both continuous and they are differentiable on the open interval AB. And moreover, the G derivative of G was not equal to 0 for all x in A and B. Then there is points A x0. There is a point x0 in open interval AB, at which fb minus fa divides gb minus ga equal to derivative of f x naught divide g derivative of g x naught. And to be more visualized, let's see the axioms. In these axioms, there exists a curve, and there is 2 points. There are GA, and the other one is, this is GB, and the other one is GA FA. And we connect to these 2 points. And we get a segment. And in this curve, there must exist a point, and the point's tangent is parallel to the segment. This point, you can say AB. And we can get a formula equal to FB minus FA divided GB minus G, and it is they are equivalent. So that is the Cauchy mean value theorem. Then let's go to the Lagrange Remainder Theorem. First of all, we will have the idea of how to prove the Lagrange Remainder Theorem. First of all, we'll give a Taylor series, which is fx equal to fx naught plus x minus x naught, and the first prime, first derivative of x, and plus x minus x naught squared divides 2 factorial times second derivative of x naught. And the last term will be x minus x naught power n divided n factorial times the nth derivative of x, f x naught, and plus the arrow Rn. The arrow Rn after n terms is given by Rn equal to integral from x naught to x, and the n plus first derivative of f t times x minus n power n divided n factorial dt. And lastly, we'll use the Cauchy mean value theorem, and this can be written as arrow equal to f n plus first derivative of f x star, and x star is in the interval x naught to x, divides the n plus 1 factorial and times n minus n x naught power n plus 1. And this is the definition of Lagrange theorem. Lagrange theorem is in the neighbor of the point x naught, and n be a negative integer. Suppose that a function f from I to r has n plus 1 derivatives, and each point x not equal to x naught, and there exist points C strictly between x and x naught such that the Lagrange Remainder Theorem formula. And first, let's consider or write the summation of k derivative of function f divides k factorial times x minus x naught power k as a Taylor polynomial. And the function will have a contact over all the x at x naught. And it follows that if we define the function in the R from I to R, and the arrow will equivalent to f minus the Taylor polynomial for all x in I. And notice that fx will equal to fx because if every in the Taylor polynomial, if every x naught equal to x, and they are finally will cross cancel, so it will only left fx term. The same as fa. If we plug in a into the Taylor polynomial, and we will get the pk x. And we substitute these two equations into fx minus px. We will get fx minus fa. And from the Cauchy mean value theorem, that is fx minus fa will equal to gx minus ga equal to fx minus gx prime. And we'll get this function. And we put gx as x minus x naught power k plus 1 into the previous formula. And we will have fx minus px equal to fx minus a power k plus 1 divides k plus 1 factorial times k plus first derivative of f x naught. And after move the terms pk into the right hand side, we'll have exactly the Lagrange Remainder Formula. And that's it. And here is the reference from advanced calculus. Well, thank you very much.